The methodology just described has been applied to the case study of the St. Mary's Church in Venice, built in the late 15th century. The church is vulnerable to flooding events, especially high water events in the Venice lagoon, but also to earthquake and fire hazard. In relation to fire hazard, the church is not equipped with any anti-fire system, including smoke detectors, extinguishing systems, evacuation sites, and anything else. In relation to flood hazard, the church is not equipped with high waterproofing system. There are no sub-basing or electro-hydraulic drainage systems. In relation to seismic hazard, the church is not equipped with appropriate anti-seismic systems. The only significant anchoring elements are 10 chains connecting the side walls of the nave to the height of the eaves, which have the purpose of absorbing the vault's thrusts. First of all, specific fact sheets have been produced. Then, each fact sheet has been filled in using the literature available information and especially expert evaluation. For example, when evaluating the fire risk for furnishing coatings and structural elements, the expert assigned a high value considering the presence of barrel vault made of wooden material and wooden furniture. As far as the earthquake risk is concerned, a low value was assigned in consideration of the box-like structure. For distributive roots, the expert assigned a low value considering the regular plan and the facilitated evacuation system in the case of flood. Both smarter weights and fact sheet value have been implemented into the evaluation model. This worksheet represents the basis for the compilation of the online questionnaire. The data collected are implemented into the European Interoperable Database. The model is composed by two sheets. The first sheet is a dynamic and it can be filled in by the user, also having the possibility to exclude some indicators from the evaluation without compromising the final synthetic index. The second sheet is static and it represents the maximum risk scenario, where all the indicators have the highest value. If the user decides to exclude some indicators in the dynamic sheet, those indicators will be also excluded for the maximum risk scenario. In relation to the fire risk, the indicators of staff for emergency prevention and the type structure of the building record the highest local and global values. In relation to earthquake risk, the condition of architectural and urban context and the functional typology are the most risky components. In relation to flood risk, the geomorphological condition, the contrast of risk, and the functional typology record the highest local and global values. At the end of this process, it is possible to have a complete overview of the achieved results. The fire risk represents the most risky parameter, reaching the 66.73%. The earthquake risk index is the second risky parameter and it records the 62.93%. The flood risk index is the less risky parameter and it records the 56%. The values obtained by fact sheets and smarter have been aggregated. In this way, the parameters are aggregated into synthetic indexes of hazard and vulnerability through the weighted average for fire, earthquake, and flood risks. The histogram shows the representative results obtained by the questionnaire compiled during the first user forum. According to the expert, considering the general aspects vulnerability form for seismic risk, the element planimetric configuration is the most risky because the regularity of a structure is one of the first elements for a good resistance to a seismic vibration. For the flood risk, considering vulnerability form, The element building prevention system is the most risky among the considered indicators. The most risky parameters are represented by the local hazard for the fire risk and the vulnerability function for both fire and seismic risks. It is interesting to notice that the application of this methodology to evaluate the Santa Maria dei Miracoli Church is considered reliable for the evaluation of other cultural assets within the ResCult project. The smarter methodology is efficient in this field because it allows to indicate what is the most vulnerable aspects of a cultural asset and what scenario can be predicted in consideration of an extreme event. Fact sheets permit to suggest which is the risk of the cultural asset, taking into account its real situation by expert evaluation. The spreadsheet allows to summarize all information into a risk indicator, and it could be available on the European platform to evaluate the risk of several cultural assets, immediately visualizing the risk factor.